In example 6, you will find the volume of a solid formed by two intersecting graphs, rotated 2 pi radians about the axes. The first step is to find the points of intersection of the graphs of the given functions. You can do this algebraically by setting the two equations equal to each other and solving for x. Using your GDC, graph the function, and either tracing on the graphs or using the appropriate commands, you find that the points of intersection are 0, 0, and 2, 1. To rotate about the x-axis, use the x values of the points of intersection as your lower and upper integration bounds. Recall that the formula for finding a volume of revolution about the x-axis between x equals 0 and x equals 2 is pi multiplied by the integral from x equals 0 to x equals 2, a function f squared minus function g squared. Integrating the difference of the squares of the functions and substituting the lower and upper integration bounds for x, you arrive at 3 pi divided by 5 cubic units. In part B, you will find the volume of the same region formed by the intersecting graphs, but this time the region will be rotated about the y-axis. The integration bounds are y equals 0 and y equals 1, which are the y-coordinates of the points of intersection. Next, obtain the functions in terms of x. Y equals root x divided by 2 implies x equals 2y squared. Y equals x squared divided by 4 implies x equals 2 root y. Substitute these functions in y and the boundaries in y into the volume formula. V equals pi multiplied by the integral from 0 to 1 of 2 root y squared minus 2y squared squared dy. Simplifying, integrating, and evaluating at the boundaries, the volume of the region rotated about the y-axis is 6 pi divided by 5 cubic units.